Welcome to Technically You, where big ideas go down easier than seawater through a desalination filter. Today, we're diving into the amazing world of desalination plants.
Awesome. So can we really turn ocean water into clean drinking water without it tasting like aquarium soup?
Yes, and believe it or not, we've been doing it for decades. Desalination plants are one of the coolest tools we've got for solving water scarcity, and the tech behind them is only getting smarter.
All right, give it to me straight. What exactly is desalination?
Desalination is the process of removing salt and other minerals from seawater or brackish water to make it safe for human use, typically for drinking, agriculture, or industrial purposes.
So basically a giant Brita filter for the ocean?
Kind of, but industrial strength. Desalination plants use complex systems that handle millions of gallons of water per day.
So how do they do it? How do you remove the salt from seawater?
There are two main methods. Thermal desalination, this uses heat to evaporate water, then condenses it back into liquid, leaving salt behind. It mimics the natural water cycle. And there is reverse osmosis, RO. The most common modern method. It forces seawater through semi-permeable membranes that trap salt molecules but let pure water through.
Reverse osmosis. That sounds like the small system I have under my sink.
Right, it kind of is. But it's high pressure, high tech, and surprisingly efficient when done right.
So building one of these plants, what does that look like?
It starts with selecting a coastal or brackish water site. Construction includes intake systems to pull in seawater, pre-treatment facilities to remove debris and biological matter, RO membrane banks or evaporation chambers, post-treatment to balance pH and mineral levels, and brine disposal systems to return concentrated saltwater safely to the sea.
Sounds like a water factory on steroids.
Exactly. And it's all engineered to minimize environmental impact, at least in the newer designs.
Let's talk tech. What's inside these magic machines?
In reverse osmosis plants, high-pressure pumps force water through membranes at 800, 1,200 psi. The membranes are made from materials like polyamide that filter out 99% of salts. Sensors and AI systems monitor flow, salinity, and membrane health in real time. Some plants even use renewable energy like solar or wave power to drive the process.
So it's like super science meets sustainability?
Bingo.
Okay, but all that machinery, how do they keep it running?
Maintenance is crucial. That includes cleaning membranes regularly to prevent fouling from salt, bacteria, or algae, monitoring pressure levels and flow rates, replacing filters and pumps as needed, and software updates for automated systems and remote control panels.
So you basically need a water tech team on call?
Pretty much. But newer systems are getting smarter with predictive maintenance tools using AI and machine learning.
Okay, this all sounds amazing, but what's the catch?
There are a few. Energy use, it's still energy intensive, especially thermal methods. Brine disposal, the leftover salty water can harm marine ecosystems if not handled properly. Cost, building and operating plants is expensive. Access, not every country can afford or manage this tech. Carbon footprint, if powered by fossil fuels, they contribute to emissions.
So the challenge is, how do we make clean water without dirtying the planet?
Exactly, and that's where innovation is stepping in.
So where is this actually happening?
A lot of places. Some of the big users, Saudi Arabia, the world's largest desalination producer. Israel, nearly 80% of its drinking water is desalinated, and the United Arab Emirates, Spain, Australia, and parts of the US, especially California and Florida. Even island nations and cruise ships use smaller-scale mobile desalination systems.
Okay, paint the future. What's next for this salty solution?
Future trends include solar-powered desalination plants to cut emissions, graphene-based membranes for ultra-fast, low-energy filtration, portable units for disaster relief in rural areas, AI optimization to reduce waste and energy use, and hybrid systems that combine desalination with water reuse and recycling.
So clean water for everyone. without breaking the planet?
That's the goal. Water scarcity is one of the biggest global challenges, and desalination is part of the solution if we do it right. Any final thoughts?
Yes, desalination is more than just science, it's survival tech.
Well said. With climate change, growing populations, and shrinking freshwater supplies, desalination could be a lifeline for millions.
And now I'll never look at saltwater the same way again.
That's a wrap for today's podcast. So stay hydrated, stay tuned, and stay curious.